For week 2 of the course, we covered chapter 8, and a couple of the highlights for chapter 8 was comparing projects with the multiple year cash flows, so projects that had different lengths. The second thing was going over capital cost allowance and then doing an NPV with capital cost allowance. If you are watching this course outside Canada, which I know some folks do, most finance principles are the same globally, but not capital cost allowance. That's very specific to Canada, so you can ignore that if you're not watching it in Canada. Okay, so let's go over the first thing first. The first one is multiple year cash flows. So if we look at this table here, we can see that we got 3 projects, A, B, and C. A and B are 2 years in length, and C is 3 years. Now, if we compare A and B, it's pretty clear that A is better. It's got the higher NPV. They've already told us we don't have to calculate what the NPVs are. But what about A and C? C has a higher NPV, but it's taking longer. So there's two ways to determine which one is better when the timelines don't align. The first way is called the chain replication method. And in this method, basically what you do is you keep repeating the projects until they have the same timeline. So you find the lowest common multiple. Okay, so repeat the projects, and you'll see when I do the example, until the timeline is the same. And the second method is called the EA-NPV, which stands for Equivalent Annual NPV. And this is where you convert the NPV into an annual amount. And it's not going to be as simple as just dividing the NPV by 3 years, because there's time value of money involved here. Okay, but let's do method 1 first. So the chain replication method. In this example, you first will find the lowest common multiple. So this is like high school math. In this case, A is 2 years and C is 3 years. Therefore, lowest common multiple of 2 and 3 is 6. Okay, so you keep repeating the project for 6 years until you get to 6 years. So you repeat each project until you get to 6 years. And that way you're comparing the two things that are, in the same timeline. So let's look at project A. So I'm going to do it once, and it'll be NPV of 624. Okay, now if I want to get it to 6 years, I'll have to do it a second time. So that becomes year 3 and 4, and it will also be an NPV of 624. So what I'm saying is, if it was possible to just keep redoing this project every year until you got to the 6 years, we'd have to do it 3 times. Okay, so what's the total NPV in this case? We can't just add the 3 together because the third time we do it is much later in the future. So we adjust for time value of money. So the total NPV for project A is going to be, the first one we don't have to discount. It's already 624. We know that. The second one, it occurs in 2 years. So it's divided by 1.15 because the discount rate is given as 15% to the power of 2. And then the third one is the 624 divided by 1.15 to the power of 4. And we get a total value of 1452. So that is the present value of the net present value of project A if you did it 3 times in a row. Now for C, we only need to do it twice in a row to get to 6 years because it's a 3-year project. Okay, so you got 1, 2, 3, and the net present value of this one was given as 816. And if we did it a second time to get to 6 years, we would also get a net present value of 816. So what's the total NPV of C? Same as we did for A. It will be the $816 today, plus the second time we did it, it was 3 years into the future. So divide by 1.15 to the power of 3. So we get a total NPV of 1353. And you can see here that A is better when we do the chain replication method.